Hey guys, in this video you're going to learn 3 simple techniques that can massively reduce the cost of your AI automation workflows without sacrificing quality and intelligence. For example, I was able to reduce the cost of this AI newsletter automation workflow by 91% and this Reddit AI reply and outreach automation by 89%. So I can guarantee you that if applied correctly, you can save a lot of money for yourself and for your clients. See, most AI automation workflows are structured as follows. We start with the input, which essentially consists of our user instructions and some data that you would be feeding into the AI. And then the AI would take it and do something with it. Simpler actions would consist summarizing or sentiment analysis, and those would just require the basic LLM node. And then there's also more complex actions involving tools and memory that will be done by the AI agent. And once the processing is done, it then generates an output which can come in the form of text, image, video, or voice. And the quality of the output really depends on the type of model that you use for the AI as well. For example, if you're using Cloud Opus, then it's a very intelligent model, and so the output generated will be a lot better, especially for complex tasks or questions. And then sometimes you can also use a cheaper model like a Cloud Haiku 3.5, which is very cheap, but it doesn't guarantee a good and high quality output. And it's usually used for simpler tasks. Now, in each of these 3 areas, there are significant cost reduction opportunities. In input, we can reduce the text that we pass into the AI. And then for processing, we can use a cheaper model, which means that per token, we are using less amount of money. And then for output, we can also generate the same kind of output, but with less text. Now for today's video, we'll be ignoring the AI processing bit because there's also quite a lot of things that you can do here to reduce costs for your overall AI automation workflow. But I don't really want to cram them all in this video. I'll be releasing a separate video that talks about this. And so if you want to be notified when the video is eventually released, make sure you subscribe and also turn on the notification bell. Now, if you look at this graph, which shows the total usage per day for Claude 3.5 Sonnet, where do you think there is most room for you to reduce cost? Well, I think it's pretty obvious that it is in the prompt tokens. And the prompt tokens refers to our input, i.e. the instructions and data we feed into the model. Which begs the question, why are we consuming so much input tokens? Most people tend to forget or ignore the fact that the system prompt is being reinvoked every single time you call an AI node in n8n. Let me show you visually what I mean. Let's imagine this is a single call to the AI. The red represents the system prompt and then the blue is the user prompt. This is what it looks like when we call it 100 times. A wall of tokens. Now, that's a lot of unnecessary tokens wasted. Here's why. System prompts are static, which means they don't change no matter what data you feed into the AI. Let's take a look at an example in n8n. Alright, so this is very much a workflow in progress. I'm still working on this, but I think it serves as quite a good illustration to my point. On a high level, what this workflow does is that it searches for relevant posts on Reddit based on the product that I'm trying to promote, and then insert my product as a reply to the original post. The point is to increase the reach of my product using Reddit. Now, if you zoom into a sub part of this workflow here, you'll see that what this part does is that it essentially gets all the Reddit threads. A Reddit thread looks like this. There is the post body here, and then you'll see that subsequently we also have the replies. It will then feed all of that Reddit thread into an AI agent, which will then classify whether or not a post is relevant for my use case. Let's say in my use case, I'm trying to promote my SaaS product. And so it looks through 126 posts and then see which one allows me to insert my product as a solution to the original post. And so this is what this agent does. And if I open this agent, you'll see that there is a system prompt, and then there's also the user prompt here. In the system prompt, it looks like that. And so you'll see that it is pretty much a static prompt. Everything is fixed. There's no variables here. And even with this variable, it's pretty much the same thing because this is the variable that I fixed at the start. And it would be the same thing for all 126 items here. And the only variable thing is the Reddit post, because here for every single 126 posts here, everyone will be different, right? Because they're all different posts. Now, you can quickly see that there's a lot of wastage that's going on here because each time when we are calling the AI agent, which by the way, we are calling it 126 times. So of each of the 126 times that we are calling the post intent classifier agent, we have the system message at the top, and then we have the Reddit post, which is the user input at the bottom. And so across 126 times, what we're doing is we're doing something like that, where we have a system prompt and the user prompt, and then we're calling it 126 times across. And all of them has the same system prompt. And so you quickly see that if you're trying to optimize for tokens here, it is very obvious to just use one system prompt and then append all the Reddit posts underneath so that we are only calling the system message once, and then subsequently it will just be all the Reddit posts. Ideally, the AI agent will be able to understand our instructions and then just be able to process all the Reddit posts. And that would look something like that. And so this whole box here represents a single call, and you'll see that there's one system prompt here, and then everything else subsequently is just the Reddit posts. So what we've done here is that we have removed all the repetitive system prompts. This way we can significantly reduce our token usage. So with that said, let's take a look at a concrete example of what this means in terms of costing. Alright, so in this table here, you see each row represents a call to the AI agent. And in our Reddit examples, each row represents one of the 126 items. So there are three things to note here. The first is the number of input tokens, which is the sum of the system prompt tokens plus the user prompt tokens. And I've already populated these number of tokens beforehand so that we can have a smoother discussion here. And then we have the dollar per token, and we're using GPT-5 here. And you can see that in OpenAI's website, in input, the price is $1.25 per million tokens. So I just directly copied that, and then I put it inside here, and then I just divide it by a million to get dollar per token. And then after that, we have the total cost, which is the total number of input tokens multiplied by the dollar per token. Now again, one row is for one Reddit thread. Now let's say in our case, we have 126 Reddit threads. And so we'll do that 126 times. And then you'll see that for one run, which is for the 126 items, we'll get up to about $1 in terms of token costs. And to be fair, 126 Reddit threads is not a lot. I think a more realistic number would be somewhere around, 1,000 or so. But let's say in our example, we are using 126 Reddit threads. And let's say we do that 1,000 times, right? So we process 126 Reddit threads across maybe a span of 2 to 3 years, for example, then it would add up to about $1,000. Now, if we then use the approach where we have one system prompt, what would that look like if we are able to combine just one system prompt and then the rest would just be user prompts? So you just go to this tab here. You'll see that what I've done here is I have kept to only one system prompt and then remove all the subsequent ones. And then after that, I've kept all the user prompts in place because these are all the Reddit posts. I mean, in reality, all of these number will be different because all posts would have kind of like different number of tokens based on the length of the thread. But in this case, just for simplicity, I've kept them all the same. And you'll see that we can quickly almost trim off half the cost. Here is 50 cents. Here we have almost $1. And then over a span of 2 to 3 years, maybe it's like $900. And then here we have 500. So we're trimming off $400 across 1,000 runs. So then the question is, how do we go from this to this in n8n? Well, one way that you can do that is simply by using an aggregate node. So what you can do is, here we have all 126 Reddit threads, right? And so what we want to do is we want to combine all 126 items into a single item. And we can do that with the aggregate node. So if you just connect this, and then we set it to all item data, and then we just run it. All right, so I've ran this, and now you'll see that we have this, right? So initially we started off with 126 items, and then now we have one item. If I were to collapse all of this, you'll see that it only has one item, whereas in this case, we have many items, right? And each of them are essentially a whole Reddit thread, and then we have like 126 of these curly braces. Now, once we have one item, what we can do is we will then pass that into the AI agent, change this to this instead. Now you'll see a bunch of objects, but what you can do is you can just insert json.stringify, and this will give you all 126 items in a single run. So now instead of running the system prompt 126 times, we're just doing this once, and then we're appending all the user input under a single run. Now, the problem with this approach is that you're going to find yourself facing the problem of context overload, where your model is going to take forever to run, and the performance and accuracy of the output would be mediocre at best. The reality is that all LLMs have an effective context window size that you should never exceed. The effective context window varies for different AI models, and it is basically the point right before the steep drop in accuracy. This means that while you can technically feed in a large number of tokens, in reality it is effective only until a certain threshold. For example, for Llama 2 7D model, it is practically not usable after it hits about 4,000 tokens. Taking again the example of GPT-4 with 128,000 claimed tokens and 64,000 effective tokens, this means that while the official context size is technically the size of this box, the AI becomes unusable once the token goes beyond this line. And so while it makes a lot of sense to aggregate the input data all at once to save costs, you may be sacrificing output quality as the tokens far exceeds the tipping point. A smarter and more effective way is to use input batching. Instead of aggregating all the data, we create batches. And that means instead of having a single system prompt and all the data sets piled up underneath one single system prompt, we can instead create sets. So we have one system prompt, one user input here, but let's say we want to put 3 instead. And we don't want to put too many because otherwise it will exceed the context window. And so what we will do is, now we would reduce the size of this box to only this big. This big. And then we will create sets of these instead. So, and then put it here. So this is what we would do instead. For every system prompt, we have about 3 to 4 user inputs. And the number here really depends on to what number of inputs that we can possibly fit in that doesn't heavily impact the quality of the output based on the effective context window size. Alright, so again, with our Reddit threads example, we have 126 items passing in, add options, and then click on batch processing. And then you can say add batch processing option batch size. And then you can set whether you want 3 or 4 or 5, and that is up to you. The best way to figure out what is the best size is somewhere which is a number that is big enough so that it can save you a lot of tokens because you don't waste a lot of system prompt tokens, but at the same time, it doesn't exceed the context window size as well. And one way that you can find out is really just through iteration and experimentation. So just try, setting like 20 and then 10, and then see if the output kind of like fluctuates a lot. Because if it does, that means maybe it's somewhere in between. That would be the sweet spot. And so in this case, I'm going to put 3. And so what this means is that for each call to the AI agent, it would read the system prompt and then it would take 3 Reddit posts instead of just 1. So input batching essentially allows us to strike a balance between context overload and overwhelming token costs. Which brings us to the second lever that we can pull to further optimize our token costs. Alright, so let's take a look at this example where we have the GPT-4 context window size. And these numbers essentially comes from this same report here, where if we look at GPT-4, you'll see that the claim length is 128,000 and then the effective length is 64,000. And so effectively what this means is that 128,000 is the total context window size, and then the effective length is where the tipping point is. So after 64,000 tokens, then the output quality would drop dramatically. And so we have drawn that here. So we have 128,000 tokens, and then the effective length, which is this black line here, is 64,000 tokens. And then you see that these blue balls here are essentially the input data, and then the red ones are the system prompt. Now, we wouldn't be touching the system prompt because they're essentially fixed. And then on the left-hand side, you'll see that there are some additional input data that we want to feed into the context window. And so let's say that we want to really squeeze in as much as we can from the system prompt. How do we do that? How do we fit in these 6 balls here into this context window so that it doesn't exceed the effective length, which is the tipping point? Now, there are 2 ways to go about this. One is we can look to reduce the current balls that we have within this context window and then just move them in. Or we can look to make each of these balls smaller and also these smaller so that in this way, we can fit them all in, and even more if you want to. So then the question is, what does it look like to eliminate these blue balls in n8n, right? Because we don't want to just remove data even when they are useful for us. Ideally, we want to only remove things that we can kind of like filter out as irrelevant. So let me show you an example where I've done this in one of my workflows. Alright, so if you look at this workflow, this is actually a sub-workflow of a larger workflow, which is essentially my personal AI newsletter, which I scrape posts from Reddit every day and then send it into my inbox. Within this get Reddit thread, actually it looks something like that. And where I have sort of like eliminated blue balls is as and when I get all of the posts within any given subreddits. Let's say in this case, I have about 120 items. I know that not all of them would be relevant for me, and I want to fit in as many Reddit posts as I can within a single AI agent that I'm running in a subsequent sub-workflow. And so what I've done here is I've only filtered it down to the key posts that I would really need. And I've done it through this filter node here, where I'm essentially filtering it by time and score. And so if I click inside filter node, you'll see that I filtered it by date. And this is essentially saying that I want everything that is within 24 hours. and also the score, which means the upvotes of the posts. And so this has effectively gone from 120 items or Reddit posts to 14 items, which now has saved me a bunch of tokens, because each of these posts will be pretty sizable in terms of tokens, and over thousands or tens of thousands of run. This would amount to significant cost savings. But the thing is, not all the time we have the luxury to just cut away data. But in this case, I was only able to do it because there is a very clear attribute that came out of this Reddit API, where it is essentially giving me the upvotes, which is the ups here, and then also the time of the post as well, which is this created attribute. If this type of data does not exist, you can still always filter your data by using the classification strategy, which is what I'll show you next. Now, going back to our original example of the Reddit promoter workflow that we have seen before, what this agent does is that it essentially labels each Reddit threads, whether it is relevant, true or false, and then the reasoning that it provides. Now, before I proceed, I just want to call out that this reasoning is very important, especially if you want to leave an audit trail on your agent's reasoning, so that if it ever makes a wrong decision on whether a post is relevant, then you can always refer back to the reason and then control for that particular reason in your prompt, so that in that way you can iterate and then improve the accuracy of the labeling as you go. And so what this agent gives me is basically a bunch of Reddit posts now labeled as whether they are relevant to my use case or not. And so you can see that this one is not relevant to my use case. You'll see that this one is not as well. And so actually a lot of them are not, and only a small subset is relevant to my use case. And then if we then filter it based on relevance, and so here you can see that JSON.relevance is true, we'll allow the Reddit threads to pass through to the next nodes, where we might potentially be passing it in to an AI agent. And so you can see that out of the 126 posts, we have only kept 14, and then we have discarded the other 112. Just from this, we have essentially trimmed down by 90% in terms of the total from the total number of posts down to whatever that will be passing in to get post summary is where we will use a summarization chain to summarize the Reddit threads. The last two examples that I provided is essentially involving you removing the blue balls, right? So if I go back to that graph that we've seen, essentially what we're doing is, let's say we have 100 balls and then we're cutting all 90 balls and then we're left with 10 balls. And so what that means is that if we have more additional input that comes in, we can always then feed that into the AI agent, because now we have a lot of room. But it is not always the case where we can just cut away data. Sometimes everything is relevant and there's nothing that you can cut. So what can you do, right? So basically, going back to our second solution, is we can make each of these balls smaller. And the way that we'll do that on n8n is essentially we'll be using summarization chain that looks something like that. Either this, or you can use a basic LLM chain. And so you can then pass in all those data and then just get the AI to do a quick summary for you and then generate key insights that you need out from each of those Reddit threads. And where this is really useful is, especially if you want to be reusing these threads and the key insight that comes out of it, you can just use the summary for your subsequent AI analysis. So here's what I mean. We're going to use raw product reviews now instead of Reddit threads, just to make the point a bit clearer. And usually in a marketing standpoint, what you use product reviews for is you want to, maybe innovate your product. You want to do some copywriting based on what people are saying about your product. You want to do some competitor intelligence, and you can also kind of spot trends based on product reviews as well. You can imagine that if you have all these agents that are running concurrently and you have this set of product reviews, that means every time when you want to run each one of them, you would then have to feed all of these raw product reviews into each of these agents, which is a lot, right? Because now for 4 of them, you need 4 sets of these circles. Whereas instead of doing that, you can always just summarize the product reviews into its core essence, which is, let's say you need pain points. Now, there are a lot of things that you can get out of product reviews. It can be pain points, it can be pleasure points, it can be motivation to buy, etc. But let's say in our case, we want to get pain points only, because that's our key insight for these agents. You can have a separate workflow, which will then convert all of these raw product reviews into maybe like a pain point report, a short and concise one. And so now what we have is a super concise pain point report instead of like a bunch of raw product reviews. And so this essentially saves us a lot of tokens. And so now every time when this AI agent runs, we can then just feed in this report into each of them instead of the whole wall of token here in the product reviews. Alright, so here's the best part. Once you've optimized your prompts, it wouldn't be complete if you didn't have an automated way to track how many tokens and costs you're consuming each time you run your AI workflows. Now, there are a lot of tutorials out there that shows you how to track your AI agent actions, which means what are the actions that they're taking, what tools they're calling, and some actually shows you how to track tokens only when a tool is called. However, today I want to show you a way in which you can track your input, processing, and output tokens all without having your AI agents invoke any tools. Alright, so this is the setup that allows us to do just that. On the right hand side, you'll see this spreadsheet, and this is where we track our LLM tokens. Now here you'll see two tabs. The first is just to track the tokens, and then the second one is more on observability, where we're tracking what are the tools that the AI agent is calling, etc. Now on this first spreadsheet here, you'll see that there are a couple of things going on. The first is just like metadata stuff like workflow ID, execution ID, and then you can even feed in the client ID, right? For example, if your AI agent is serving across multiple clients, or your clients wants to track who is their AI agent that you're building for them kind of like serving, you can always have this client ID here. And then here we also have the client ID, which just gives you a way to kind of like track across all your users, for example, who are the ones who is burning through a lot of tokens, and then maybe you can do some actions based on that. And then we can also track what are the models that we're using and their corresponding input tokens, output tokens, as well as the total tokens, which is just the input plus output. And then we also have the cost component here as well. So you can see that everything here is very transparent. The AI agent does not need to call any tools for any of these to be recorded. And then on the other hand here, we have the observability tab where we can see the tool use. For example, here I messaged Perplexity to do something, and then this is the result that it gave me. And so you can see that it kind of like gives you a 360 view of your AI agent, what it's doing, and also how much it is spending. Okay, so I'm just gonna run through an example of how this works, right? So what I'm gonna do is I'm just gonna delete all of this first so that we can start with a blank slate. Okay, so now that we have a blank slate, I'm just gonna start talking to this AI agent, and then I'll show you an example where it doesn't call any tools. For example, it doesn't call Perplexity. And then we're gonna throw in another example where we'll use Perplexity to do something, and then we'll see how that is tracked in the spreadsheet, and also how the tokens are then locked within the spreadsheet as well. All right, so let's do that now. Let's just say, hi, how are you? So now you can see that it didn't call any tool, we didn't use Perplexity, and yet the AI agent was still able to lock the tokens within the spreadsheet, as you can see here. Input token was 161, which represents this hi, how are you? And then the output tokens is 24, because the output is I'm good, thanks, hi, how are you, how can I help you today? So that's the output tokens. And then the total tokens adds up to 185. And then we also have the associated input and output cost as well, because as you know, if we go back to OpenAI, input and output tokens have very different cost structure. Input is $1.25, for example, and then $10 for output per million tokens. And so we will need to definitely track this separately, and then we'll get the total cost, which is this plus this. Now let's go to our next example where we will ask AI to do some research on Perplexity and then give us some key takeaways. Let's just say, can you research provide me key takeaways, please? And so you can see that as it runs, it will message Perplexity, and then while it is messaging Perplexity, you can also see that it locked the tokens that it used to message Perplexity within the spreadsheet as well, as you can see here. And then now that Perplexity is given a reply, you'll see that the AI agent is now processing it as an input, as additional context from the research that is done in Perplexity. And then you'll see that it will then log another time within the spreadsheet just to indicate that, hey, now this is the input that I've gotten from Perplexity. See how it's running now. So it is saying this is the input that I've gotten from Perplexity, and you can see that in the input token is quite a lot here. And then now I'm going to be generating some output, right? Or if let's say in this case, it is going back to Perplexity, that means that the output tokens here actually means that it is then going back to Perplexity, asking for research another time. And then now it's going back to the AI agent. And then it will probably call this spreadsheet another time just to log one last time before it then gives us the final output. So if you just wait for this to finish, you'll see that it logs the final time. And this is where we have the output, and then it then logs into this another spreadsheet, which is this observability spreadsheet that we have here. And then if we come here, you'll see that it essentially gives us the output. For the tool use, it also says that it has run this, right, which is message a model in Perplexity. This is the question. Can you research about AI automation for me? As well as all the other like metadata stuff as well. So you can see that it essentially tracks everything that the AI agent is doing very accurately, and every single step along the way as well. Now, if you want more details on how to set this up exactly, you can check out my video above where I talk about how how this workflow runs, what it looks like, and also how you can set it up within your own environment. A quick caveat that I wanted to call out here is that this involves using a LangChain code node, and this is actually only available for people who are self-hosting their n8n instance. Alright, so today we have just covered the prompting side to reduce the cost of your AI automation workflows. In practice, there's actually a lot more things that you can do to both increase the accuracy of your AI agents as well as reducing costs at the same time, such as via smart design of your AI agents, how you structure them, AI model switching based on the complexity of the tasks, and model optimizations as well. Now, I'm still cooking the video at the moment, and so if this is something that you're interested in, make sure to subscribe and hit the notification bell so that when any of these videos are released, you'll be the first to be notified. In the meantime, if you're interested, you can check out this video which recently exploded on Reddit. It covers the fundamentals and principles that every n8n beginner should definitely know before building your first AI automation workflow. Also, if you want to learn more n8n related techniques, make sure to check out my growing community of n8n enthusiasts in the video description below, where I post updates, things I'm working on, and you get to vote on what types of video I release next as well. Alright, thank you for tuning in. My name is Han. Don't forget to like the video, and I wish you a great day. Bye.